All right, pre-calc students, last unit of the year, no final exam, not even sure we're going to have an exam on this, but it's going to be of value, especially all you seniors that are going to be taking calculus in college. You're going to have a really big head start, maybe compared to a lot of your peers, having had a unit on limits and this mini unit on derivatives. Would have been a lot more if we would have had a full year, but it is what it is. So let's start. First of all, we're going to talk about a visual perspective. And the first basic function we'll talk about is anything that's linear. Rate of change, typical rate of change is things that have pers in them. Miles per hour, feet per minute, miles per gallon, revolutions per minute. Anything that compares 2 units. This example of the graph here, miles per hour, it's nice and linear. That means its slope is what? It is constant. It always stays the same. That's the great thing about linear functions. They have a constant slope. Whatever this rise or run here, it's the same here, it's the same there. All right, but not everything is linear, obviously. We've done lots of different functions. We've done quadratics, we've done exponentials, we've done logarithmic curves. How does a curve differ? A curve has an ever-changing slope. Okay? And how do you measure a curved slope? You can do it one of 2 ways. Okay, you can find what's called the average rate of change. That's saying the slope over a certain particular interval of time. So let's say from here to here. So I'm going to pick that point right there. I'm going to pick that point right there. And what I'm going to do is I'm not going to find all of these slopes along this curve. I'm just going to find the slope of that, what we call secant line. So the average rate of change is slope of secant line, 2 points, old school slope, change in y over change in x. We'll focus today on that one, the average rate of change, slope of secant line. However, there is something else called the instantaneous rate of change. That is the slope of the tangent line. Tangent line means touches the curve only at one place. So our question for the next couple days is, how do I figure out the slope of a tangent line to a curve when there's only 1 point? There's no 2 to do the change in y over change in x in. That's just some food for thought. Let's move on with our average rate of change. All right, so first function we have here. I just drew a curve. I put a bunch of points on there. There's 0, 15. There's 210, 412, 620, 825, and 12, 18. Find the average rate of change over a given interval. Intervals are talking about x values. So that means 0 to 4. I am visually talking about this green line right there. I have 2 points, change in y, 12, minus 15, change in x, 4, minus 0. 12 minus 15 is negative 3. 4 minus 0 is 4. So that slope is negative 3/4. Could that green line have a negative 3/4 slope? It most certainly can. All right, I think we got the hang of it. Now let's do another one, 6, 12. Maybe we won't need to do all 4. From 6 to 12, again, x values. Again, a slightly negative slope. Well, we can't do 2. They're almost the exact same. We'll have to do a third. So what do we got? Change in y, 18 minus 20. Change in x, 12 minus 6. 18 minus 20 is negative 2. 12 minus 6 is 6. That slope is negative 1/3. And again, a visual representation of that slope, down 1 over 3, down 1 over 3. Let's do one real steep one. We'll pick letter D as a red line going through the point 2, 10, and the point 8, 25. Average rate of change, we got this now. 25 minus 10, slope of secant line, 8 minus 2. 25 minus 10 is 15. 8 minus 2 is 6. 15 over 6 reduces to 5 over 2. That line would have an up 5 over 2 slope, up 5 over 2. Okay, average rate of change of a curve, slope of secant line given 2 points. All right, what if we said the average rate of change and I gave you the function? Well, to make it easy, we could graph it. I can graph that, 0, 0, 1, 1, 2, 4, 3, 9. Negative 1, 1, negative 2, 4, negative 3, 9. And we could pick an interval, 0. Let's do this one, because that's on our graph. -2 to 1. I'd be finding that slope right there. What do I have? Change in y's would be 1, 2, 3, -4. I'm sorry, +4. My bad. -1 over -2 minus 1. Change in y over change in x. 3 over -3. That's a -1 slope. Down 1 over 1, down 1 over 1. Perfect. 0, 3 would be the same thing through the vertex and through this point up here. And what do we have? Change in y, 9 minus 0 over 3 minus 0. 9 over 3 equals 3. Again, up 3 over 1. 1, 2, 3, 1, 1, 2, 3, 1, 1, 2, 3, 1. Got it. But what about this one? The interval from 1 to 10. Let's think about this. It's not on our graph. Way, way up off the chart. Where is it? 10, 100. Well, what if I said, find these average rates of change without graphing? What we could do is find f of 10, the y value. 10 squared is 100. Find f of 1, which is 1. Change in y are the function values. Change in x are the x values. 99 divided by 9. The slope of that line, really, really steep from the origin to the point, 10, 100, up 11 over 1, up 11 over 1. Got it. So that's slope of secants. We did it graphically. We did it graphically and numerically for the blue one. Now let's do it just numerically. Now in my mind's eye, I could picture what that graph looks like, a radical graph. I got it. With a left shift of 5, so it's going to look like that. Not anything wrong with finding average or finding a numerical idea and back it up with a visual. We need the y values. Let's plug in a 4 here. Square root of 9 is 3. How nice are you, Mr. Ward? Giving me nice values. And square root of 4 is 2. So now we do change in y, 3 minus 2. Change in x, 4 minus a -1. 3 minus 2 is 1. 4 plus 1 is 5. 1/5. Very gradual slope. Why? Because at -4, this point was, pardon me, at -1, this point was 2. And at +4, the y value is 3. So as you can see, the slope of that line through the point -1, 2, and 4, 3 is very gradual, up 1 over 5. Perfect. All right, 4 to 20, we won't bother with the graphical. We'll just do a numerical. F of 20, f of 20. 20 plus 5 is 25. Square root is 5. F of -4. -4 plus 5 is 1. Square rooted is 1. 5 minus 1 over 20 minus -4. 5 minus 1 is 4. 20 plus 4 is 24. 4 divided by 24 is 1/6. An even more gradual positive slope. Because of the shape of that radical graph, I would never expect to see a negative average rate of change because that curve never goes down. It's never decreasing. Another cool thing to remember, the average rate of change is in relationship to the function increasing or decreasing from that interval. All right, let's keep moving. So now we're going to have a function, but it's not just going to be a function, rather it's going to be a value that means something. So in this case, an object's displacement or its movement can be defined by the function given. F of t equals t cubed plus 3t squared minus t minus 3. T is seconds, and let's call f of 3 meters. Okay, so the average rate of change from 0 to 3, we're still going to do what we have done. F of 0, I can do that quickly. It's just the y-intercept, -3. F of 3 equals 27 plus 27 is 54, minus 3 is 51, minus 3 is 48. So now I have the average rate of change, slope of the secant line, 48 minus -3, which is plus. 3 minus 0 is 3. 51 divided by 3 is 17. Now, the only reason why I gave you these other two questions is because it's worded slightly different. From time 2 to 5. Easy. The interval of 2 to 5. Plug them in, change in y over change in x. But how about this one? Over the first 6 seconds. What does that mean? Again, from 0 to 6, f of 0 is -3, f of 6, I just did some quick arithmetic in my head, 315, change in y, 315 plus 3, change in x, 6 minus 0, 318 divided by 6, the average rate of change is, what is that, 53. All right, and if you changed, what did we say t was? Seconds. And we said, so that's x, seconds. F of t is meters. So meters over seconds. Meters over seconds. In general, when we're talking about a function that represents an object's displacement or movement, the rate of change is the velocity. So we would be finding the average velocity of that object. From time 0 to time 3, it averaged 17 meters per second. From second 2 to second 5, it averaged, oh, we didn't find it. The answer was 59. And from over the first 6 seconds, it wasn't that same velocity all the time. It's a curve. So the velocities are going to change. That's where that tangent line is going to come in. But the average velocity is 53 meters per second.